Hey guys, and welcome back to Chem Squad Chemistry. Today we are going to be talking about electrolytes as well as some colligative properties because it didn't get to fit on that last video. So let's go ahead and get started with electrolytes. We are going to be continuing our notes on pages 1, 2, and 3. I believe we are on page 2 right now talking about actually, we're on at the very top of page 3, so go ahead and turn there. So we're going to be looking at the difference between a non-electrolyte, a weak electrolyte, and a strong electrolyte. We're going to have to use our imagination. Typically, we have a demo to see this, but not today. So an electrolyte is something that dissociates, which is a word you should already know. Remember, dissociate means that it completely breaks down when put into solution. So we see that Na and Cl from salt completely dissociate or break down into their ions. So an electrolyte is a compound that completely dissociates when added to water. So that's the definition you need to know. An electrolyte is a compound that completely dissociates when added to water. And we're going to look at 3 different examples here to see what the difference is. So let's start over here with strong electrolytes, since I already have that drawn. An example of a strong electrolyte is a salt, which we know is NaCl. What happens when I put this NaCl into water is that it's going to dissociate, and it's going to become an Na ion and a Cl ion. Now keep in mind this is happening with thousands and thousands of molecules. So floating around in this water, what we have are positive ions and negative anions, which are able to conduct electricity. So electrolytes are able to conduct electricity. So looking at our battery here, we see that we have our positive and negative plugged up. The energy is able to flow through this liquid and continue on to the light bulb to cause the light bulb to light up. So strong electrolytes completely dissociate in water, allowing them to let energy flow through them, thus causing a bright light bulb to pop up if you were to have that. A weak electrolyte is something that does not completely dissociate in water. A good example of that is acetic acid, HC2H3O2. What happens with acetic acid is it's going to break down partially. Some of the molecules are going to fully break down, so there's going to be a lot of H pluses, there's going to be a lot of CH3O2 minuses, but there's still going to be some just straight up acetic acid floating around in this water. So because of this part not dissociating, it does not allow it to conduct electricity as well. So you can notice at this picture that we have here, as the energy flows from the battery, it's still going to be able to help the light bulb light up. It's just not going to light it up as bright because does not have complete dissociation. So meaning the molecules didn't break apart completely. And the last one, you can probably guess what the definition is a non-electrolyte, and that's when molecules don't break down at all. So sugar is primarily made of C6H12O6, which is glucose, and it's in the shape of like a little like hexagon type deal. When we put sugar into water, lots of times people think that it completely breaks down. What you're actually seeing is you're seeing these molecules separate from one another. So, sugar molecules are long chains of these rings, and when we put them in water, they separate from each other. But there is not going to be any dissociation of this at all, right? The C6, the H12, and the O6 are still going to stay together. So there's no dissociation at all of these sugar molecules. They're just floating around in the water, which is why it tastes so sweet to you. But because there are no ions being created, there's not going to be any flow of electricity. That's why we see that the light bulb does not light up at all. So there you have it. A non-electrolyte is going to have only molecules, no dissociation. Weak electrolyte is going to have some molecules and some ions, so partial dissociation. And strong electrolytes are going to have full ions only, so the entire molecule dissociated. Moving right along to our next topic, we have our colligative properties. Colligative properties, which is a weird word you've probably never heard before. But colligative properties attempt to explain what happens to a solvent or a liquid as we put stuff into it, right? Salt water and pure water are not going to act the same. They're going to have completely different properties because of the salt being there. It's going to make different things happen. So that's what colligative properties are trying to explain. we know that if we go, to the beach on on a cold day, for some reason it can be below 32 degrees outside, but that water still won't be frozen. So why is that? The answer to that is the colligative property, is what we're going to be talking about. So one type of colligative property is known as the freezing point depression. You may know the word depression. It means down or something like that. Freezing point depression is when the freezing point is going to be decreased because of the solute dissolved. So in this case, we're talking about salt water versus just pure water, right? Salt water versus pure water. Salt water versus pure water. We know that pure water freezes at 0 degrees Celsius. Salt water is going to freeze at about -8 degrees Celsius. Now, it's different for all types of salt water. The more salt, the lower it gets. This is exactly why in the wintertime, when it's about to snow, you see people putting salt on their driveways or salt on the road. It's so that the water won't freeze. What's happening, we have to look back at molecularly. What's going on? Why does this salt cause the water to take longer to freeze? If you look at these two pictures that we have here on the left, we see that the molecules have nothing inhibiting them from getting closer together, right? And we know that as we go from a liquid to a solid, all that has to happen is we get it colder, the molecules are going to slow down, they're going to get closer together, and they're going to be able to turn into a solid. What the salt does is it effectively blocks this from happening. You can see these little green dots, they represent salt, and they're keeping the water molecules from getting close together. It disrupts it and it destabilizes it, causing these bonds to take longer to form, meaning it has to get colder for it to be able to freeze. So the salt literally just gets right in between those molecules and causes it to freeze. Keeps it from freezing, meaning it has to be colder. Another thing that can happen is boiling point elevation. Now, the word elevation is normally talking about going up, so boiling point elevation. Pure water, I'm just going to write pure and salt. Pure water boils at 100 degrees Celsius. Salt water boils at about 108 degrees Celsius, give or take how much salt's in it. So if you want to cook your food faster, you're actually going to be able to cook it faster in this salt water because it's able to get much hotter before it starts to boil. Adding salt, you have to go back to the molecular level. Those salt particles are going to be absorbing some of the energy from the boiling water. So the particles of salt start to absorb some of that energy as you're heating it up, which allows the temperature to get much higher. So colligative properties can be changed just by adding more or less solute to a solvent. So we're going to go ahead and talk about some separation techniques. I'm not going to, read these slides to you. You can go ahead and read them for yourself. We see that decanting and centrifuging are two ways to separate, different things. Decanting, a fancy word for this, is, like straining. Is another type of decanting. Like if you have spaghetti and water and you want to keep the solid, you're going to decant it. So decanting is to keep the solid. Centrifuge all has to do with gravity. And what's going on here is, if you can imagine being in one of those like spaceships at the fair, and you're laying against the wall, and as it starts to spin, it pushes you up against the wall. The same thing's happening in this centrifuge. You see on the left that we have some particles in a liquid. We start spinning this very, very quickly. This whole centrifuge starts moving, and those liquids gets pushed to the side. The solids gets pushed to the side, and we're able to collect those. One example that this happens with is when people donate plasma. They take their blood, they spin it in a centrifuge. You get the liquid back, and they keep the solid. So that's one type. Distillation, you're probably very familiar with this. This is, especially if you're from Franklin County, moonshine capital of the world. This is how we make moonshine. But distillation helps separate things based on boiling point. So if you have, a pot that has alcohol in it, water in it, corn in it, all sorts of things in it, and you want just the alcohol off, you heat it up to a certain temperature, the alcohol will evaporate, and you can capture that. So you can read more about distillation. Filtering and evaporation. Evaporation is very similar to distillation. You're just boiling off what you want. Filtering is just like a coffee filter. This is where you want to keep the liquid. You want to keep the liquid. Sorry, I misspelled that. You want to keep the liquid, so you pour the coffee and the coffee grinds into the filter. You throw away the coffee grinds, you keep the liquid. So remember, filtering and decanting are very similar, but decanting you keep the solid, filtering you keep the liquid. Lastly, there's chromatography, which is probably the most confusing one, but there's a video that you can watch that is on the website to help you explain it. But chromatography basically means color writing, and if you take a color like, say, black, we know that black is made up of every color. And we can actually run electrical currents through this, and it will start to separate those colors out. So, it might look like the blue is only going to move up to here. The green's going to move a little further. And eventually, if you keep doing this, you're going to, you see like this change in color as it goes up. Because of the electrical currents moving through it. And again, you can watch chromatography in the little video, and it'll explain it to you. So that's all for today. That covers chromatography, separation techniques, as well as the end of solutions. If you have any questions, please watch our videos. Thank you and have a good day.